Good afternoon, everyone, and it's a pleasure to be here today and open the proceedings and the webinar for the Ecoacoustics work. I'm Hamish Holewa. I'm the Director of the Planet Research Data Commons and the ARDC. The Planet RDC is an initiative of the ARDC which focuses on Earth and environmental science, data challenges and programs, and the work that we are presenting here today is one of those programs. So it's very exciting to see this work here today. I'd like to first start though by acknowledging the traditional owners of the lands that I am joining here from today, which is the Ngunnawal people here in Canberra, and I pay my respects to elders past and present, and I implore you to add your acknowledgements in the chat function of the Zoom windows here as well. So over the past 2 decades, ecoacoustic researchers have wrestled with the hard slog of processing acoustic data, and only over the last couple of years has it been possible to build recognisers that pull species identifications from the thousands of hours of recording at scale. Tools like BirdNET have transformed the field, but they don't work well for every species, region, or soundscape. Today, what we'll see and what we'll be exploring is that next step, a workflow that allows anyone to build a custom recognizer, run it across their own data at a record speed, access the national compute and data and processing capacity, and combining Ecosounds with Google's DeepMind's Perch foundational models. This work, as I explained previously, sits within the Planet RDC's machine observation program, which is changing how Australia collects and processes images and acoustics data for species detections and environmental change. The scale here really tells the story. 1.2 petabytes of audio, 825 years of recordings across 6,000 locations and 47 million detections, a figure that was and has grown 40-fold in the past year thanks to AI classifiers and the work of the team that is presenting here today. Now, whilst scale is important alone and doing scale alone isn't enough, we need to work together or we fail. If we continue to build siloed data sets and isolating processing solutions, we simply won't be able to turn this massive influx of data into actionable insights and conservation insights about making decisions on what we do with the environment, how we do it, and where we do it. By integrating machine observation methods, by merging acoustics, camera trapping, and shared processing pipelines, we can move away from the fragmented projects that we all have been working on hard, and we can move towards a cohesive national Australian machine observation program. With Ecocommons acting as tools for downstream analysis and reporting. And together we are building a national environmental machine observation observatory at an unprecedented scale. This, with our other colleagues within NCRES, within government and with states, we are actually addressing that challenge about knowing where species are, what the environmental change is, and how does this influence our decisions and actionable insights. So without further ado, I'd like to hand over to the two people at the forefront of this work, Dr. Anthony Truskinger and Dr. Philip Eichinski from QT Ecoacoustics. Sorry, Phil, I probably just cannibalized your last name a little bit there, so I do apologize about that. But I'm going to hand over to you for the rest of the webinar, and please do not hesitate to add any questions or comments into the chat for a Q&A session at the end. So thank you very much, and over to you, Anthony and Phil.
Thank you, Hamish, for that warm welcome. Okay, let's get started. Yes, my name's Anthony. I work with the Open Ecoacoustics Research Group as part of Planet RDC, and today we're going to be focusing on some demos. We're going to try and demonstrate an end-to-end workflow for ingesting some data, building a recognizer, and dealing with the results. So what today is not really an introduction about who we are, what we do. That we've done before in a bunch of other webinars, and if you want to go look them up, then they're on YouTube on the ARDC's webinar channel. And there's lots of great talks that kind of explain what we are and what we do. We're going to really focus on some practical aspects today. This is what we're going to do today. We're going to create a project, upload some data, build a recognizer, run some analysis, do some verification, have a look at what reports we might be able to get, and export some data. Some of these steps we're still building, but this end-to-end workflow is available today, and with a little bit of help, it'll get better and better. So I'm going to start talking. Phil will take the middle bit, and then I'll finish up as well. So, the very first step we want to do, say we're starting a new project, we're going to upload some data. We're going to use this website. It's like Ecosounds, but it's it's staging data, it's all fake. And we do this so we can play around with demos a little bit and not affect real data. As you can see, there's some very test quality names here in these projects. But the first thing you might do as a user on Ecosounds is to create an account and log in. And then you would create your own project. We're going to work with a Powerful Owl project on Ecosounds a little bit later, so I'll just name this Powerful Owl project. I'm going to give my project a good description, which describes the data and the project and all the stuff about this project that we would want to share with other people. This is essentially an archive of your acoustic data, so we want to describe it with as much information as we can. We choose a license for our data, and we can choose who is allowed to download the files that we upload. Today we're going to restrict it so only the owners of the data can download the original recordings. And we've made a project. A project is this logical collection of the work you're going to do when you will process your audio data. If we look in the permissions tab, by default you will see that it is not public. It is a private project by default, and the only person that has access is the person who owns the data. You can make it public by flicking those switches, and you can make it public by private by unflicking those switches. And you can add access to specific people to your project as you so desire. So I gave myself access, my other account. So yeah, private by default is the takeaway point there. The next thing we want to do is add a little bit of structure. So we'll add a site. Just for demo purposes, I'm going to choose the QUT campus. A site is kind of like a location that has a couple points on the ground where sensors are deployed. We're going to put a sensor in A block, right next to the chancellor. Choose a time zone, and we've made one point. Go back to our site, we'll make another point, and we'll choose S block this time. Sites have locations and they have time zones. If you have lots of sites and locations, we have a batch upload process available to you. But this is just the basic structure you need to start uploading data. And you can see we've got a site with 2 points here on our map. So the next thing we want to do is upload some data. By default, uploads are disabled for every project because we don't know who you are, and we need to verify that you're not some person on the internet with malicious intent. So contact us, send me an email, and we flick this little switch here, and then suddenly you can upload data. We're just going to do a little test upload today. You have a history of your uploads here. No uploads yet. This is a new project. Choose batch if you have an SD card full of files, which most people do. There's some instructions here you can follow. We suggest you install WinSCP, which is some standard file transfer software. I've done that before. Once you click that link, WinSCP will open, and this is just standard file transfer software. I've got some demo files here on the left for my computer, and there are some folders on the right, and that's the Ecosound servers. And to upload a file, we're just going to pick one of these files, drag it across, and it will transfer. I'm just going to transfer 2 files today. Really short demo, because we don't want to wait forever. But this process can support tens of thousands of files and well into the multiple tens of terabytes of data. So you can drag whole folders and SD cards across and transfer those. Once you're done transferring, hit the finish uploading button here, and then we'll go through and scan your files. We'll check for lots of little problems like duplicates or overlaps or whether we have enough metadata or not. In this case, I've chosen files that will not have any problems for the sake of the demo. And we can see with all these little green ticks that no problems and we don't need any more information. And if we do have problems, you'll get little exclamation marks or errors, and there'll be some information down here, give you suggestions on what to do. If everything is all good, hit continue, and those files get added to our database. The reality is most deployments have a couple dodgy files from the sensors, so there will always be a few errors, but that's a basic upload done. Now, I actually have no idea whether these files are actually any good. I just downloaded some random sample ones, but we can go see what they look like. That's a very boring random file I picked up. Got some wind, nothing twittering, but those are files that have been uploaded. That's it. What's this one? Okay, someone doing something. And that's the basic process of uploading. As soon as your files get uploaded, we start processing them in our analysis queue. By default, we generate BirdNET embeddings and Perch embeddings for every file that's uploaded. And those embeddings are what we can use to build a recognizer, and that leads us into Phil's part of the workshop. Over to you, Phil.
Thanks a lot. Let me just share my screen. Is that coming through?
Yep.
Great. Okay, yeah, my name is Phil Eichinski, and I'm going to be walking you through the next step in the workflow after you've uploaded audio and it's had Ecosounds automatically generate those embeddings. We can then leverage the API of Ecosounds to pull those embeddings from Ecosounds along with the audio and build a recognizer. The sort of the workflow or the pipeline of building the recognizer is shown here. We've got the embeddings database that we need to build from those embeddings that were pre-generated on Ecosounds. That's a small subset of what could be a very large project. We create a database of those embeddings, and then we can search for our target species. And because of the way that these embeddings work, which is that they are compact representations of small audio clips that have been transformed from the raw audio to a representation that allows them to be easily compared with each other. We can then search for labeled examples, add those labels to our database, and then once we've built up enough of those labeled examples in the database, we can just build a simple linear classifier. And this is a very fast process because working with that embedding representation, it's a small, compact representation of the audio. All of the hard computational work that you usually associate with deep learning has been pre-done and is available to be downloaded by the API from Ecosounds. So I'm going to jump over to this tab. So this is a graphical user interface that's available as a web app, and we can set you up with this if you wanted to use it yourself to build your own recognizers. It's not Ecosounds, but it interfaces with Ecosounds. It pulls down audio, pushes up annotations, and that sort of thing via the API. So there's a help section over here. I'm going to hide that just to make the screen a little bit easier to read on the video. And there are these different tabs here which roughly correspond to the steps in that workflow. So the first thing to do is to do a little bit of configuration. We'll need to put in our Ecosounds API token because you may be potentially working with your own private data, and this is not Ecosounds. We have to make sure that you sort of authorize this Recognizer Workshop platform to pull your private data, and that's done through this Ecosounds token. You can get that on the Ecosounds profile page, just paste it in here. And the other thing is that we need to add our target label. So I'm going to add in a species that I want to build a recognizer for now. And I'm going to choose the trusty old eastern whipbird because it sounds cool and because I can usually tell when something's a whipbird, whereas I can't for almost every other species of bird. And once we're done that, we can just verify that it's worked. So we can go over to the status, refresh that, database is loaded, things like that. The next thing to do is to build the database of embeddings. So this is a bit of a more lengthy process. You'll put in the number of recordings you want to pull down, the number of embeddings total that you want to have in your database, which project you want to work with. Because it takes maybe, I don't know, between 20 minutes and an hour or something, depending on how big of a database you want to build. I'm not going to do that now. I've already pre-done that, which is why we can see that it's already got 200,000 embeddings. So that's 200,000 5-second audio segments that have been converted to an embedding representation and pulled down from Ecosounds into our database. The next thing we can do is to add some labels to some of those embeddings so that we can start building the recognizer. There's two ways we can do that. We can use the search tab to search for examples, or we can, if we happen to have some labeled examples already on Ecosounds, we can pull those in and add those to the database. So I'll show you how that's done now. Configure whichever project we want to look for labeled examples, and as long as we've got permission to access that, we can use that. I'm using this project, which is from Gympie National Park in Queensland, that's been made open source by Yvonne Phillips, so I have permission to use that. And I can just say fetch labels from server, and it's gone and made a web request, made an API request to find whipbirds in that project. It's found 620 positive examples. It's found 0 negative examples, which means that previously in this particular project, we've imported or annotated some of the audio, but we haven't imported any false positives and then verified them as false positives, which is why nothing's come back as negative. And then, so that's what we could potentially add, and then we're happy with that, so we'll add that to the database. And then this is the summary of the results from that. So, and these are all of the individual audio recording IDs and offsets and whether they were added or not. So now if we head back over and just refresh this, we can see we've got a bunch of labels in our database. But you're not always going to have the situation where you can just pull in labels to your particular species. So we can also just search for examples using the search tab. So you can search with Xenocanto. I've found this whipbird example on Xenocanto. Can you hear that? Okay. So I can just copy that Xenocanto ID and paste it in here and load the remote query. It's a bit clunky because I've zoomed in so much, so I've got to scroll a lot, but here we can see it's loaded that 11-second clip. Now, these perch embeddings are made on 5-second clips. That's just the decision that is fixed, made by the people who made Perch from Google DeepMind. So we need to select a segment of that's 5 seconds long, and we can just drag this across to make sure that our whipbird example gets into that 5-second clip. And then we can select that 5-second window and search our database. Now what that's doing, it's pulled the raw audio from Xenocanto, and now it's putting that through the Perch deep neural network using TensorFlow. The first time you do this, it takes a little bit of time because it's got to load up TensorFlow and after that, it's a little bit faster. And now we've got some search results. So these are things from our unlabeled database that have closely matched this example according to the embedding representation. And so we can play those if we want. This one's just at the very end there. And any that we think are positive examples, we can label with a green by clicking once, and any that are negatives, we could label by clicking twice to make it orange. But I think they are all actually positive for this one. So that's just telling me that the embedding representation is very good at capturing this particular call type. And when we compare this example to our database, we get good matches. This one is, yep, that's also one. So now we can add those, save the responses. Up here it says we've saved 10 labels, and if we go back to the status and refresh that, we've now got 630 examples. So that's way more than enough that we need to start training a recognizer. We don't need any negatives to start off with. So we'll head over to the train tab. And here are some parameters that you can edit if you want. So the algorithm parameters are to do with the machine learning algorithm. And most of these are usually fine just to leave as the defaults. And here we've got some labeled data parameters. So this is saying that we're going to take 90% of those 630 labeled examples and use them for training, and the other 10% we're going to use for testing. So we can test on examples that haven't actually been seen during training to get a sort of an idea of how well the recognizer is doing on that labeled training data. And then we have this concept called weak negatives. So we don't have any negative examples at the moment, and you do need some negative examples for the training. So what we can do is just take random examples from our data, and because the vast majority of stuff that you listen to is not a whipbird, if you take a random sample, we can just sort of assume or guess that it's not going to be a whipbird and treat it as a negative for the purpose of training. But we weight it less than the actual stuff that we've got labels for. And we can control here how many examples we do. Now, because we've got so many positive examples and no negative examples, I'm going to bump these up a little bit. So I'm going to bump it up to 0.2, and I'm going to bump this way up to like 128. So that's saying for every 32 actual labeled examples that we're going to use, we're going to look at 128 random examples, assume they're negatives, but then weight them at 1/5. And that will help us to balance out that extremely skewed data set. So I hit train classifier, and that's how fast it takes to train it. So it's extremely fast because it's just a simple linear model, and all of the hard computational work has already been done in generating the embeddings. So heaps and heaps of computational work has gone into training the model that generates the embeddings, and then a reasonable amount of computational work has gone into actually just putting the audio through and converting it to the embedding representation using that model. But then once we've got that embedding representation, things are really fast. We get some metrics here. Not that important at the moment because we don't have a good set of negative examples. So once we've got that classifier trained, the next step is this refine step where we search for examples using the classifier in a similar way that we searched using an individual example before. And by verifying those results as positives or negatives, we then are adding new examples to our labeled set. And that will then enable us to train the classifier again and improve it each time. So if I search for the best match, that'll give us the things that the classifier is most confident with. So that's gone through and used our linear model classified everything in the database and given us our highest scoring results. And then we can label those. So this is only returning things that haven't been previously labeled. That's a whipbird. That's a whipbird. It looks like it's doing pretty well. Seems to have. I'm going to say that's one. I'm going to say those two are also true. So I think it's doing really well. And this here is the score. So the highest scores that are coming out of this recognizer are about 2. Okay, so I'm going to say the responses there. And that's added a little bit of more positive examples. That's not terribly helpful for us though, because sort of we're just giving it more examples of what it's already good at finding. What would be more useful is to verify the things that it's least sure of, and that's called margin sampling. So I'm going to change this search strategy to margin sampling and search again. Now this time we'll get a whole lot more negatives, I predict. Yep, here we go. So we can go through these. That's not one of our target species. I don't think I need to listen to that one. I don't think I need to listen to that one. That one is, but it's faint. So I'm going to label that as a true positive. Sometimes we get failures. This is just the audio couldn't come back from Ecosounds for whatever reason, so we can just skip that one. This is negatives. Okay, so now we're getting somewhere. We're starting to add some useful responses. So this is things that the classifier wasn't very sure of, and now we've given it some more information to work with there. We can do that more times, or we can go back and train. So if I train the classifier again now, I'm training it with more examples, and then I'll come back and refine it again. And probably the most straightforward process is to do a page of margin sampling, label it, and go back and train. And you can do that 5 or 6 times. It doesn't take very long, as you can see, and pretty soon you start getting something that's going to work reasonably well. So that's a negative, I think. I'm going to say that all these are negatives. Ooh, that might have been the start of one. So I could do 2 things here. I could go and look on Ecosounds at the context to see whether that actually continues out, or I could just leave it blank. Might as well look at it. So if I open this in a new tab, that's now showing me this example, but on Ecosounds with a little bit more context. And so we're looking at the middle 5 seconds here. That actually might be a whipbird, but I'm even with the context, I'm not confident personally. I don't know if anyone wants to chime in the chat. I can't see the chat while I'm sharing my screen. Can I get a thumbs up from Ant whether he thinks it's a whipbird or not?
Well, I ain't the expert here.
All right, I'm going to leave it blank then because I'm not sure. Just finish this page. Okay, so we're still getting plenty of negatives here. That's not a bad thing at this stage. The other thing you can do is to look at a particular target score. So rather than looking at 0, 0 is the score at which it's least sure, because anything with a positive score it's saying is a positive example. Anything with a negative score is saying it's a negative example. That's just how the training has been done, so that it tries to split it at the 0 score. But we can put, say, a score of 1 here, and that'll get us things that it's not as sure about the top scoring ones, but is still thinks it's not its least sure ones. It still thinks are whitbirds. So you can see this one looks like it is. Oops, that is. Yeah, so so these are still helpful for it because it's not as sure. Um, ooh, yeah, that might be one. I'm not going to spend too much time investigating in these in detail in the interest of time. Um, just sort of want to find one negative one. I'm going to say that's negative. Okay, so I can save those responses. So the idea is you can do a few iterations of this refine and train step, and eventually you get a recognizer that should be doing a pretty good job. And so what I can do then, I'm going to sort of skip the rest of these. That's just the status, which we've seen, the logs, and this is just to run it over our entire local small subset. But we don't do that much because most of the time we want to run these recognizers over much larger sets of data and even different projects from the ones we've trained on. So I'm going to scroll down and I'm going to save the classifier and call it fills whipbird recognizer. I don't know, V1. I'll save that. So now I've got that saved as this JSON file. It's very small. It's only 7 kilobytes. If I open that with Chrome, this is what it looks like. So it's got our list of classes. We've just got one class in this one. You can do it with multiple classes. And then it's got this beta, that's the weights. So for each one of our 1280 embedding numbers in the vector of embeddings, we get a weight, and then that's base 64 encoded. That's why it's not just numbers that you see, but this is actually a list of 1280 numbers. Those each get multiplied with the embeddings and added together, and then this bias is added, and that's just a mathematical function that produces a score. And if the score is positive, it's saying it's a whipbird. So that's great. We've got a recognizer here, and we can run that over data locally. But what we probably want to be doing is to share that with other people, or at least make it in a way that we can share it so that other people can run it. Or if you want to publish and cite it, you can just give a link to it. So we have a way that we're recommending for doing that, and that's on GitHub. So this is GitHub. This is a website where you can collaborate on. It's originally for code, but any sort of text-based documents, it's really good for. It's a version control thing, so you can update it with new versions and go back and see old versions. And what we've got here in the Ecoacoustics organization of GitHub is a repository template. So things in GitHub are organized by repository, and there's a special type of repository, which is a template where you can just clone based on that one. So if I create a new repository, and I call it, I don't know, feels good recognizer. Probably want to call it a better name than that. Perch embeddings with bird recognizer. I can make it public or private. I'll leave it as public, and I can create a repository. So now on my own GitHub profile, I've got a repository that is based off that template, and it's got a sort of folder and file structure that it's got a whole lot of suggestions basically of the kind of things that you would want to ship with your recognizer, things like license, how to cite it, any source code to run it, things like that. And so at the very base most basic, what I can do is I can go into this example recognizer that it comes with. You probably want to rename it. I can go into artifacts, and I will. So this is just a sort of example of just for demonstration purposes, and I can edit this right here in the browser and delete that, and instead go to my recognizer. So if I open that with something that I can just copy, just copied and pasted that on the other screen, paste that in. That's just a little bit of text because we've base 64 encoded that vector of numbers. It can be pasted as text, and then I save it by hitting this commit changes, and then save like that. And now my recognizer that I've trained in about 15 minutes or something is now available for anyone to use, including for Ecosounds to use to run over whatever data it wants to, or you want to run it on. So that's a good time to switch back to Anthony to explain how that all works.
Thank you, Phil. Okay, yeah, so Phil just showed us how to build and train a recognizer with Perch and how to save it and publish it. And then we're going to now talk about how we do the analysis, do some verification, reporting and exporting. So back to our demo. We were working with this Powerful Owl project. This is a BirdLife project that Rob and Callan Alexander have contributed to. You see there's a lot of data in this project. It's being used for a citizen science project at the moment called the Powerful Owl Call Detective Project. To run the analysis job, you would go to the analysis jobs page and see what analysis jobs exist for your project. At the moment, users can't create an analysis job. We will make that for you. So reach out to us when you've built your recognizer, send us a link to your published recognizer, and we will set up a job here that can run automatically. You can see at the moment for this project we're running BirdNET and Perch embeddings by default for everything in this project. I'll just give you a little example of another project where we've run a recognizer. So for the A2O we're running the BirdNET classifier. It's sitting there churning away, generating results for something like 1.7 million files. It's just running through and generating results. We paused the job last week, but it's generated 35 million events so far, most recently some rufous songlarks. So as you upload data, you can configure these jobs to run your recognizers that you published and built with Phil's workshop on Ecosounds, and we'll set up those jobs for you. So those jobs will produce annotations, observations, and you can start looking through them here with the search annotations button. And I've got that preloaded over here. And yeah, this is some of the annotations that have been generated for this project. There's powerful owls and other things that aren't labeled. But today we're interested in whipbirds because that's the example that we're working with. Okay, here are some whipbird annotations that were imported. These are from BirdNET, I think, so they got a nice little score there. But yeah, that sounds like a whipbird. There's a bunch of whipbird annotations here, and so something you might want to do, which you really have to do for most classifiers, even at the moment, is still get some kind of sense of how effective they are, how well they're working. And so you want to go through for at least a partial subset of those annotations and verify that they are actually correct. So you have some wider understanding whether the population of results is actually accurate. These have already been verified. So what this means is somebody has gone through, one person's gone through and said, yes, that whipbird is correctly labeled from the recognizer. I've been practicing for this demo for a while, so I've been going through labeling and marking things as correct. This annotation here doesn't have any verifications yet, but does have a little unsure on it. And so this is just a little search pane where you can see the annotations generated by your analysis jobs. If you want to start verifying them, you hit the verify button. You can choose a species you want to target. You can choose your task, and you can choose between improving quality, so that's getting many people to verify the same samples, so you get consensus. That's important for a citizen science project. Or you can choose between improving coverage, so that's spanning out over your data set and getting more verifications over more data. This page will load, and here's one I prepared earlier. This is our verification interface. It's a grid dedicated to answering questions very quickly about whether the labels applied to something are correct or not. You can configure it to work with different grid sizes. So let's go down to 4. And you can select different tiles and make decisions. You can use keyboard shortcuts like Shift to select a range, or Control to select subsets. And you can play the samples and then use keyboard shortcuts, or you can click the buttons to make decisions about the page. So this is not a whip bird, so I can choose no. I'm not sure about this one. I have no idea. I'm not a birder. Doesn't sound like a whip bird to me. Unsure? No. Nothing here looks like a whip bird. No, 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 no. Or you can make it a decision for an entire page altogether. None of these look like... oh, that might be a crow actually. You play all of them at once. And so I think they're all labelled incorrectly. This one here looks interesting. Yep, that's a whip bird. And for the sake of the demo, no. People who practice with this interface can verify thousands of calls in an hour, and that can really help improve the quality of your data sets. And you can use those, Phil can use those verifications to reinforce the quality of a recognizer on successive training runs. Here's some other data. These are the BirdNET detections, and you can see BirdNet's doing really well here. They're all with birds. I don't need to look at that one. Yes. And so when you have a lot of data that's consistent, you can process these things pretty quickly, provided you know what you're doing. I don't necessarily know what I'm doing, so maybe I made a mistake there. Feel free to call me out. And then when you get to little patches where it's a little less sure, you can work through them one at a time. So that's the verification step. You can farm that out to people who work with your project. Everyone who has access can do verifications. Or if you're interested, we have a project at the moment called Call Detective, which makes custom dedicated citizen science websites for singular projects. So this is the Call Detective project for the Powerful Owl project. And you can see it's pretty much the same interface. It's just a little bit simpler, singular focused, only on powerful owls. If that's something you're interested in, reach out to us. So we've talked about verification and analysis. Now we have to talk about reporting. So Ecosounds is a bit of a generalized tool, and we don't aim to build reports for every scenario, but pretty soon we're going to be able to produce reports for every project, which gives you some simple ideas of, you know, what is present in your data and where. So this is generated from the data of the Powerful Owl project we were just looking at, and you can see here things like, you know, where there has been audio recorded, where analysis has been done, species accumulation curves, distributions for different tags, frequency counts, and DL plots. And these are all customizable with date, range, site, tag, filters, and even analysis jobs. You can even turn sections of these reports on or off. They're coming soon. But for anything that is custom, you probably just want to download the annotations yourself and do some analysis. So on our project page with a download annotation button, choose a time zone you want all the times in. You have to choose this because sometimes projects cross state borders and the events are in different time zones. So this lets you select one time zone where they can be generated and shown to you all in a consistent format. This is quite a big project, so this takes about 20 seconds to download. There it is. 60 megabytes of CSV if I remember rightly. I did not, it's 85. And then we can open that CSV and feed it to whatever post-processing script we want to deal with. So we've got some whip birds here, and we can see all the tags, the dates, when they happen. And we also have all the verification data here too, in case your project's gone through verification. So big project, but let's scroll down and find some verifications. Here we are. We can see that the powerful owl on this row has been marked as incorrect by one person. And unsure by that person. And you can see, this one has received 6 verifications as incorrect, so that's definitely a bad result. And you can use those negative verifications to feed into the recognizer workshop as negative examples, and that will hopefully make your recognizer better. So that's exporting data. As I said, we're always building. One of the things we're going to be doing soon is exporting data in a CamTrap DP format. So if you've worked with camera trap data, you're probably familiar with this format. There's a bioacoustics adaptation because the result sets are pretty similar. And so that will be a standard way to export and share annotations, observations that you'll be able to configure and download and generate for yourself and feed that into different tools like the ALA or Ecocommons. We're also working on a bunch of other features that will make our platform a great way to store and share your data long term. That's all we have for our demo today. We'd love to hear your questions, but thanks for joining us. I was answering some questions in the chat before. I'm a bit behind, so if anyone wants to speak out some questions, feel free.
So one of the things I saw, two things I saw in the chat that came up. One was a question about running recognizers with a project that might have different kilohertz files in them, and another question around bats, which I assume it all works for bats, but I've never done bats. So.
Yeah, so the model that we're using for these recognizers, Perch, built by Google DeepMind, it resamples everything to 32,000 hertz. So it'll work pretty effectively for calls up to about 16,000 hertz. We do have the capability to run custom recognizers though, so we can run BirdNET or Perch classifiers or something you built yourself. So we can package those things up into a Docker container and run those for you. So you can BYO recognizer if you have one available. For bats, we don't have that much bat data. We don't really focus on it. We do terrestrial audio mostly, but we have no inherent limitation for storing bat or ultrasonic data on Ecosounds. We support sample rates that are really high. But Perch won't work for bats probably unless they're in the audible range, which I don't think many are. There's lots of questions in the chat, like does this feed into state or federal governments? That's a great question. We're going to be enabling ALA export soon, and that'll be something you can opt into. And ALA data feeds into lots of places. But yes, we're trying to be the primary data storage platform for states and governments, so they will be able to use that data as well.
One of the other questions I saw was, are the steps available? So maybe I'll see if I can drop the Open Ecoacoustics thing in the chat. But I'm guessing, Phil, what you've just done is not there yet, but coming soon kind of thing.
Is that regarding bats, sorry?
No, so sorry. Instructions for
Oh, okay.
doing all this.
Yeah, sorry, I might have hidden that. There are instructions for using the actual recognizer workshop built in. I'll go back and share my screen for 2 seconds just to show you what I mean. Um, and this one, I think. So if I go back here, I hid it because it takes up a bit of screen space, but you have all of these instructions down the side here that um, explain sort of like practically what to do, like what the process is, but also some of the theory as well. And that's something I sort of will update as well whenever people have questions. Um, um, Instructions for getting the whole thing sort of set up and getting started with it is contact us and we can set up an account for you and sort of even start off the process a little bit for you as well. Does that answer the question?
I think so. Yeah. And there is the Open Ecoacoustics website, which I've dropped into the chat that also has some
Oh, yeah.
resources and there's some stuff that's useful for folks there as well.
There's a bunch of other questions that are coming up. So one question about costs. So at the moment, Ecosounds is free to use up to about 50 terabytes. After that, we will engage you for some kind of contribution. And longer term, we need to make some more sustainable decisions. But generally, for small projects, yeah, Ecosound is absolutely free to use. And all of our work is open source too. So we showed you an ideal workflow today using our tools. But you can actually just take our tools and use them by yourselves in your own workflows. So Phil's classifiers can run in a Docker container on your computer or your supercomputer. You don't need to use us. We just want to make it easy for you. Generally, yeah, individual detection is not something we focus on. Some people have done it, but yeah, if your recognizer can detect individuals, then that's great. But I don't. But it's not something we focus on. There's a question from Clara about referential calls. I'm not sure what that means. Is that like call playback, do you mean?
I'm guessing like Canto, like a library. Is that maybe?
Oh yeah, absolutely. You can deploy recorders to find reference calls to train recognizers on. Canto has a huge library of reference calls, and you can upload to there. Or if you have a passive acoustic monitor, then you can upload your data and use it as a training base to build a recognizer that you apply to different data. Have I missed any other questions?
I think there was a question about, I might have dropped out, from Clara about at what level of accuracy from the recognizers would you imagine could diminish the need for point counting at sites?
I think that's kind of up to the ecologist. The recognizers are generally you can sort of through the verifications of calls from different scores, you can get an idea of how well it's separating them around the some threshold, and or how well it's just at least putting like true positives above negatives in terms of the score. Um, and once you get a sense of that through some verifications, you can then decide sort of yourself whether you want to always verify everything that comes out of the recognizer. So it would still cut down on some work in terms of like going out and spending time in the field anyway. Um, but every case is sort of different. Some things are harder to recognize than others. Sometimes the the accuracy changes because of some change to the environment as well, which is a bit harder to know, but sometimes you can sort of guess that yourself, and you might want to re-verify things just to sort of recalibrate what your what inferences you want to take from it. So yeah, basically the answer is not very helpful. It's like take a look at the scores, take a look at the examples at different scores, and sort of decide yourself. You might find that when you look at the top scoring example per hour, um, it's if it's above, you'll be able to use that to get almost like 100% accuracy on whether it's there in that hour or not, and then that's a very small amount of verification that you need to do in order to get a really big coverage of for your monitoring plan. Um, I'm not sure if that answers the question, but and I'm talking from experience of my job is to help build the recognizers and build this software, and I'm talking from experience of what people have tended to do with the results that they're getting out of our collaborators and people we're working with. But everybody seems to always want to verify things and very rarely just trusts results blindly.
So we're at time now. So as we come to today's webinar, I'd like to extend a sincere thank you to our presenters for sharing their expertise and insights and experience with us. We really appreciate the time and effort they've put into today's session. And I'd also like to thank everyone who joined us and contributed to the discussion. Excellent questions and comments and engagements have been made, which is really valuable for everyone involved. We hope you found today's webinar informative and useful, and you'll continue the conversations and connections we've started here. If you are interested in registering to help the team prioritize onboarding datasets into ecosystems, I'll just share my screen. There's a tiny URL you can use, and there should be something in the chat window as well you can use as well to link to and to register. And if you want to find out more about events like this and upcoming events, we have the next one in the pipeline already. So please sign up to the Planet Research Data Commons newsletter and the ARDC newsletter, and you'll be notified when we have upcoming events. So you can join us for the next one. So thanks everyone for their time and participation, and have a great rest of your day.